All right, so we're going to take a look back now at the definition of a definite integral. So we introduced this in our last lesson. We're just going to take a closer look at it today. All right, so we know that the definite integral gives the area under the curve. And the way it does that is by finding infinitely many little rectangles and adding up their areas. So if the subintervals are equal widths, we get something that looks like this. And we can define that area as the limit as n goes to infinity of the summation of f of c sub k delta x. And so the way we interpret that is the limit as n goes to infinity is saying, okay, let's have infinitely many of these things. The summation is adding up all of these things. And the things that we're adding up are f of c sub k times delta x. Well, f of x gives us the height of the rectangle, and delta x gives us the width of the rectangle. So with that f of c sub k times delta x, we're saying find the height of the rectangle for some value of x within the kth subinterval, multiply it by the width, and let's add them all up as we have infinitely many of them. So that f gives us the rectangle height, delta x gives us the rectangle width, and we're adding them all up. So here's the definition of the definite integral. And we know that our more common notation is this, using our integration symbol, that tall, narrow S. So here's what it is going to look like in practice if we're trying to go between these two notations. We have our more common notation on the left, we have our definition on the right, and we've changed up the definition a little bit. Where we had delta x, we have b minus a over n. And that should make sense, because if you take the difference in the endpoints, b minus a, divide by your number of subintervals, that tells you how wide those subintervals are. So that's our delta x. And then on the other side, we have f of a plus b minus a over n times k. Well, again, the b minus a over n is our change in x. A is the initial value, it's that lower limit of integration. So what we're saying here is we're going to plug into that function these x values that'll give us the heights. So we start with that value of a plus that little tiny change in x, and then we multiply, so that was when k equals 1. If you plug in k equals 2, now we'll add another little change in x, plug in k equals 3, that's another little change in x, and we keep incrementally moving over in the x direction, and then plugging those into f gives us the heights of the rectangles. So all of that might have been very confusing. Let's go ahead and see this in the context of a problem. All right, here's what one of these as a multiple choice problem would typically look like. You'd be given either the limit definition and asked to find the integral, or given the integral and asked to find the limit definition. So let's break this all apart. We have the limit as n goes to infinity, the sum from k equals 1 to n. That stuff's not going to change. Where we really need to focus is the stuff that we're adding up. So keep in mind we're looking for the heights, which is the f values, the function values, times the widths, which is delta x. So this 1 over n right here, well, b minus a is 1. That's what that's telling us. So as we look down at our possibilities, that means that our integrals, our limits of integration, should have a difference of 1. So right there I can eliminate option C and option D, because those both have a difference of 3. So I've got myself down to either A or B. Now, both of those go from 0 to 1. So where up above it says f of a plus b minus a over n times k, and a is the initial value, notice that neither of those start at 1, which tells us that that 1 is actually part of the function itself. The rest of this, we have that k, and we have b minus a over n. Well, b minus a was 1, but inside this square root we have a 3, so we have 3 over n rather than 1 over n, which tells me that 3 must be part of the function as well. So it turns out my function is 1 plus 3x, which gives me answer A. So it really just comes down to sort of process of elimination, figure out the width of your interval, figure out your function, and then identify the one that matches the stuff that you know.